Alright, welcome to day 2 of Proving Triangles Congruent. Today we are actually writing proofs. So, quick refresher, the ways that we can show triangles are congruent is side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg for right triangles only. So, for these types of proofs, when you're wanting to prove triangles congruent, the first thing you want to do is study your diagram, label it with your givens, and you first want to identify what method you're going to use. Once you've identified that method, it should be pretty straightforward what is going to be inside of your proof. So let's start with this first example. CB bisects angle ACD, that is this angle here, and if an angle is bisected, that means it's split into two congruent angles. So ACB is going to be congruent to DCB. Then I'm also told angle 1 is congruent to angle 2. And they share this side BC, which means it's going to be congruent to itself by the reflexive property. So I'm going to use angle, side, angle for this proof. So let's get that down on paper. The first line is already done for us. We have both of our givens in the same statement. And what this has already established is one of my pairs of congruent angles. So I'm going to put an A out to the side just so I can keep that straight. For step 2, I'm going to talk about my congruent side, and that was that BC is congruent to itself by the reflexive property. So there's my side. And then I still need to prove my other set of angles, and that was coming from angle ACB being congruent to angle DCB because I have that bisected angle. So my reason is if an angle is bisected, then it is divided into two congruent angles. So there's my other angle. So I've now shown ASA, which means I can prove triangle ABC is congruent to triangle DBC, and that was done by angle, side, angle. And that is it for my proof. Let's go to example 2. And this one already has stuff labeled for us, but let's look at our givens. N is the midpoint of LW, which means LN is congruent to NW because if a point is the midpoint, it divides the segment into two congruent segments. And N is also the midpoint of SK. So that means that SN is congruent to NK because if a point is the midpoint, then it's divided into two congruent angles. So I also know that angle LNS is congruent to angle KNW because they are vertical angles. So this set of triangles is going to be side, angle, side. So that's what I need to show in my proof. So I'm going to start with my given. N is the midpoint of LW and SK. That was given. So that first let me conclude that LN is congruent to NW because if a point is the midpoint, then it divides the segment into two congruent segments. Alright, so there's my side. Now I want to show my angles. Angle LNS is congruent to angle KNW because vertical angles are congruent. So there's A. Then my next side is that SN is congruent to KN because if a point is the midpoint, it divides the segment into two congruent segments, or I'm just going to say same as number 2. So I've now shown SAS, which means I can make my final conclusion be that triangle LNS is congruent to triangle WNK because of side, angle, side. Okay, on to the back page. I'm told that BC is congruent to DA and that AC bisects angle BCD, so that means it's split into two congruent angles. And I can also see from my diagram that they share the side CA, so it's congruent to itself by the reflexive property. So this is going to be side angle side. So BC is congruent to DA. That was given. Also AC bisecting angle BCD was given. So there's my first set of sides. Angle BCA is congruent to angle DCA because if an angle is bisected, then it divides the angle into two congruent angles. And then AC is congruent to AC by the reflexive property. So there's my other S. So triangle ABC is congruent to triangle CDA by side angle side. Okay, last but not least, BD is congruent to AC. And then we've got that BA is perpendicular to AD, and AD is perpendicular to DC. So that tells me BAD is a right angle, and ADC is a right angle. So I'm asked about triangle BAD, which I'm going to highlight here in blue so we can see it, and triangle CDA, which I'm going to highlight in pink. So looking at those two triangles, I can see that my pink and blue overlap at AD, which means they share that side. It's congruent to itself by the reflexive property. So what I have here are two right angles. The side opposite the right angle, the hypotenuse, is congruent, and they have a shared side that's congruent, so this is going to be hypotenuse leg. So I'm going to start with my givens. And from my given information, that's established my H in HL. The next thing I need to establish is my right angles. I know that angle BAD is a right angle because if segments are perpendicular, then they form right angles. Okay. Then I also know that angle CDA is a right angle for the same reason as number 2. All right, and then lastly, I'm going to say AD is congruent to itself by the reflexive property. So there's my leg, which means I can finally say triangle BAD is congruent to triangle CDA, and my reason is HL. And that's it. All you're doing is putting your thought process to determine which method down on paper.